I'm Kumar. Welcome to my series on binomial expansions. In this video, we'll see the application of Pascal's triangle and see how it is related with binomial expansions with the help of a very important example. The question is, connect Pascal's triangle and binomial expansion to find the exact value of 1.1 to the power of 5. Now, binomial expansion can be used. We can split 1.1 to the power of 5 and write this as 1 plus 0.1 to the power of 5. So that becomes a binomial expression to the power of 5, which can be expanded using binomial expansion. Correct? Now, let me write this with binomial expansion. So we get 5c0, 1 to the power of 5 times 0.1 to the power of 0, plus 5c1, 1 to the power of 4, 0.1 to the power of 1. So their sum will always be 5. Now, of course, when there is 1, we don't really have to write 1 to the power of anything is 1. But it is kind of important here to understand the pattern, right? So therefore, I'm writing 1 to the power of 3 this time, 0.1 squared, plus 5c3, 1 to the power of 2, 0.1 cubed, plus 5c4, 1 to the power of 1, and 0.1 to the power of 4, right? And the last term, 5c5, 1 to the power of 0, and 0.1 to the power of 5. Now you could always get these coefficients using the formula. However, you can also use the binomial pattern, right? The Pascal's triangle. So in Pascal's triangle, the pattern is kind of like this. Let me write down. We need the fifth row. So we have 1, and then we could write this as 1, 1. And then it will be 1, adding these two 1, we get 2 and 1. So let me just extend this pattern. So it kind of expands. We get 2 in the center here. Now we have to add these terms to get the next row, which is 1, 3, 3, and 1. And then we get fourth row as 1, and this becomes 3 plus 1 as 4, 3 plus 3 is 6, 4 and 1, and the fifth row. Which is 1, 4 plus 1 is 5, 4 plus 6 is 10, 10, 5, and this is 1. Correct? So from here, we can actually substitute the values and straight away get, so 1 to the power of 5 will, and 1 to the power of anything is going to be 1. So we are now looking into 0.1 to the power, right? 5c0 is 1, as you know. So we get this is 1, this is also 1, and here that is also 1, correct? Plus 5c1. So 5c1, we actually, the coefficient is looking into this line. So that gives you the coefficient. So these are the 6 coefficients which we are looking forward. So we get here coefficient as 5, and this is always 1, and that is 0.1, correct? Plus the second one here is 10 times 1 times 0.1 square will give us 0.01, right? 2 decimal places. Now here we get again 10 as 5c3. This is 5c3, right? So this is 5c3, right? So let me write 5c0, 5c1, 5c2, 5c3, 5c4, and this is 5c5, correct? So we get 10 times 1 times 0. Now 3 decimal places, right, to the power, so 0, 0, 1, plus we get 5 times 1 times 0.4 decimals, right, 1, and then here we get 1 time, now 0.00001, correct? So that is what we get. Now when you expand this, what do you get? This is 1, right? 1 plus 0.5, 0.5 plus, this is 10 times, so you get 0.1 plus here 10 times this, that means 0.01, 5 times this, we get 0.123 zeros and then 5, and here it is just 0.4 zeros, and then we have it since the power is 5, right? So we get 1, 2, 3, 4 zeros and 1, correct? So when you add them up, what do you get? You get, this is after one decimal place it is 6, and then it is 1, and then it is 0, and then 5, and then 1, correct? So what do we get here is 1.61051, right? So that is how you could add them up. So what you see here is that it is sum of this. Say 1 point, since it is 10, so 10 is like 5 plus 1. So this 1 gets carried forward. So you get 1.5 plus 1 is 6, then you are left with 0 here, right? And then 1 goes in this place. So this 1 also comes to this place. So you're left with 0 here, and then 5, 1, correct? So we see this kind of a pattern. Now, my question to you is, you have seen a pattern here. Tell me, what is going to be 1.1 to the power of 4 equal to? Or what is 1.1 to the power of 3 equal to? Or what is 1.1 to the power of 2 equals to? Can you tell me that? Well, 1.1 to the power of 4, you can look into this row and then write down your answer, which is 1.4641. 4641. And 1.1 to the power of 3 will be this row, which is 1.331, right? So 1.331, and 1.1 whole square will be that row, which is 1.21, right? So it is 1.21. Even if you expand using binomial coefficient, that is what you expect, since these are the coefficients, right? So that is a very strong connection, and this really helps us to immediately find the value of powers like this much faster, right? So now the question for you is to find the value of 1.1 to the power of 6. Let this be the question for you, practice question. And you need to find this using Pascals triangle. Okay, so that is your practice question. So you have to add one more row here. Use those coefficients to write down your answer immediately. Now that should help you in many multiple choice questions, correct? So this is a very good trick which can be applied in multiple choice questions to get immediate solutions. I hope you understand and appreciate it. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.